Hi guys, and welcome to this video where I'm going to be looking at translating trig graphs. So it is quite a hard topic. It is aimed at grade 8, grade 9 candidates. However, there are marks to be had here and there are techniques you can use to try and pick those marks up. So we can start off with a basic sine graph, a basic cosine graph, and then we could do various things to it. If you cast your mind back to just normal transformations, when we're transforming shape on a set of coordinates, we can rotate, we can translate, we can reflect, and we can enlarge. Now, we don't really tend to look at rotating when it comes to trig graphs. We do, however, tend to look at transformations mainly. To a lesser extent, we can also look at reflections and enlargements. But whatever transformation we do, I think it's best to approach it in this way. So if we look here, I'm being asked to draw a graph of y equals sine x plus 1. So we saw how we would draw the graph of just y equals sine x, but we now need to draw a graph of y equals sine x plus 1. So what I'm going to do, in a similar way to how I did before, is just draw out a table with my x and my y. So my y is sine x plus 1, my x is just x. Okay, so what I'm going to do is, as you saw before, just put in, oh, missed a value out, put in several values of x, just jumping up by 35 each time. Okay, so we'll go up to 360. We can also look at the negative part of the graph as well. Same rules apply there. So what I'm going to do is type into my calculator. I'm going to very carefully program my calculator to look like that. So it's going to be brackets, sine, something, which I'm going to put in a moment, plus 1. So it's really important I have the right number of brackets. So whatever I put in, whatever my x is, I'm going to put into the bracket where you can see the cursor flashing. So what happens when I sub in 0? Well, I get a value of 1. So when x is 0, sine x plus 1 is 1. What about when x is 45? I get 1.707, so on. So that is going to be about there, let's say. When I have 90, I'm going to have 2. When I have 135, well, hopefully you will be able to recognise the symmetry is going to come, so it should be the same value that I've got here. 1.707 sine 180 plus 1 is 1. Sine 225 plus 1 gives me 0.29, so that is going to be, let's say, about there. Sine 270 plus 1 gives me 0. Sine 315 plus 1 gives me 0.29, and so on again. And then sine 360 plus 1 is going to give me 1. So I've only drawn it in that part of the, in that half of the grid of the axes. I'm just going to join that with a smooth curve. Okay, so that is my graph of y equals sine x plus 1. Now, if I compare that to my graph of y equals sine x, it's got the same shape, starts at 0, ends at 360 degrees. And again, I've got a maximum point here at 90 and a minimum down here at 270. Maximum at 90, minimum at 270. But you'll notice the big difference is it's been shifted up by 1. So actually that is an example of a translation happening. It's all been shifted up by 1 square. And that is because I've added 1 on to the end. So I take whatever my answer is, I take whatever every single point is here, and then I just increase the y coordinate by 1. As you can see, the y coordinate has been increased by 1. So when we've got a number added on to the outside, so a number just added on to the end of a function, it's going to translate by that many squares. It's going to go up or down. It's going to go up if it's positive, down if it's negative. So I must admit, when I was at school, I was always really rubbish at remembering my graph transformations. So actually I reason it out like this most of the time, just to really help me understand what's going on. Okay, actually do the translation rather than just, actually kind of go through substituting all the values rather than carrying out the translation. Think about what sine looks like and then translating it afterwards. It's much easier doing it like this. Okay, what I'm going to do then is have a look at this next one. So cos x plus 90. So again, I'm going to have a little table, x and y, which is cos x plus 90, and I'm going to work out what the respective values are for 0, 45, 90, 135, 180, 225, 270, 315, 360. Okay, so I'm going to make sure I program my calculator carefully, so it's going to be something substituted into, just got a little bit of glare there, something substituted into that gap there. So what happens when I substitute in 0? I get 0. What about when I substitute in 45? I get minus 0.7 something. What about when I substitute in 90? I get minus 1. 135 gives me minus 0.7-ish again. 180 gives me 0. 225 gives me 0.7. 270 gives me 1. 315 will give me 0.7. And 360, you may be able to predict where this is going, looking at the pattern, looking at the symmetry, is going to be 0. Okay, so I'm just going to plot those points. So it's going to be 0, 0, 45 minus 0.7. Oh, need some axes here. Let's make that minus 1, that positive 1. So I'm going to have something around there. When I have cos 90, I have minus 1. When I have cos of 135 plus 90, I have minus 0.7. When x is 180, cos x plus 90 is 0. So I'm just substituting in these values, these coordinates that I've got from up here. 225 will give me that there. 270 gives me 1. 315 gives me 0.7. 360 gives me 0. So I can just join that up with a smooth curve. Okay, so that has been my translated graph. So if I just get my graph of cos x, you can see normally a cos graph starts off at 1, dips down to minus 1 at 180, and ends up back at 1 at 360. Here I start at 0, I dip down to -1 at 90 degrees, 270 up here, and then I end at 0 again. So if I just look at my graph, let's try and see if I can see this pattern anywhere on my cos x graph. So starting at 0, dropping down, and then ending back up. Well, if I look, I can see, if I look at this snapshot here to here, that's a bit of a graph I've got. I've just drawn that bit of a graph. So again, all I've performed is a translation. Okay, I've moved this bit of the graph along. So I've translated in the y direction. Sorry, the x direction. So when it's inside the brackets, you would translate in the x direction. But if we look here, I've added on 90. But I just said I've moved it to the left. I've moved it in the negative direction. Whereas when you're adding it on, you'd expect to be moving in the positive direction. Well, whenever you are working inside the brackets, the opposite happens. Okay, so whenever you are working inside brackets, you're going to end up doing the opposite to what you would expect. So you would translate it by 90 degrees, sorry, by 90 squares, 90 whatever you want to call it, to the left rather than to the right. Okay, just a couple more examples. So y equals sine x minus 180. So I'm going to talk about this in relation to my original sine graph, and also thinking about what I've just discovered. So because it's inside the brackets, it means it's going to work in the opposite direction. It's going to go in the x direction. So a translation in the x direction, but the opposite to what you'd expect. The opposite to taking away 180. So my prediction here about what's going to happen will be a translation of 180 to the right, so in the positive direction. So if I look here, I'd be expecting to move this 180 degrees to the right. So my prediction is I'm going to end up with something. This point is going to go to here, this point will go to here, this point will go to here, this point to here, and so on. So I'm expecting to have a sine curve but have it shifted down my graph, and that pattern is going to have to continue. I'm expecting to have something that looks like that. It's just been shifted 180 places to the right. Let's just see if that does happen. So x and y equals sine x minus 180. So I'm going to just choose those values again, going up in steps of 45. Then I'm just going to program my calculator to easily sub those in. So sine something plus 180. So whatever my x is, oh sorry, it's not plus, it's minus. Whatever my x is, I'm going to put into this gap here. So when x is 0, I'm going to put that in, and I get 0. When x is 45, I get minus root 2 over 2, so minus 0.7. When x is 90, I get minus 1. When x is 135, I get minus 0.7 again. Again, the symmetry is appearing. 0. Now the next thing I'm expecting, if I imagine how that graph has gone so far, so I've gone down here, down to -1, come back up to 0, I'd expect it to carry on going. So my prediction is my next value is going to be 0.77 again. Let's just try that. Yeah, 0.707. Let's try 270. That gives me 1. I'm going to start going back down again, so my prediction is I'm going to see that root 2 over 2, yeah, 0.7, and then 0. Okay, so all I'm doing is taking 180 off each of these numbers and then working out the sign. Okay, so I'm almost bringing it forwards. I'm bringing forward all of these numbers. That's why the translation is happening in the opposite direction to what you'd expect. So I'm just going to mark these onto my grid. So 0, 0, minus 0.7. Again, I need to have my -1 and +1. So that's going to be about there. Just plotting these on using my table of values up here. And again, I'm going to get a smooth curve. Okay, and that gives me the graph of sine x minus 180 degrees. Okay, now you have actually seen that graph before. Here. They've got exactly the same values. Okay, they've got exactly the same shape. And that's not a coincidence. The sine and cosine graphs are linked very, very closely. So there are possibilities you can translate one onto the other. Okay, all you would have to do in general would be to move, if I just get this sine graph here, I would have to move this point back here, or I'd have to add on 90 degrees to move it to the left. Okay, that would turn that into a cosine graph. Okay, and the final one. Now this could come up. This is actually going to be, well, we'll see what's going to happen. So again, I'm going to do my usual x and sine minus x. I'm going to choose my values going up in jumps of 45. And I'm just going to get my calculator and carefully type this in. So it's sine negative whatever is in here. So sine of negative 0 is 0. Sine of negative 45 is minus 0.7. Sine of negative 90 is negative 1. Negative, where am I, 135 gives me minus 0.7. Sine of negative 180 gives me 0. Sine of negative 225 gives me 0.7. Sine of negative 270 gives me 1. Sine of negative 315 gives me 0.7. And sine of minus 360 gives me 0. So I'm going to plot that again, although you will see some similarities. So 0, again I need these. 0, minus 0.7, minus 1, minus 0.7, 0, 0.7, 1, 0.7, 0. It's going to be exactly the same graph as we saw before. Okay, so this is just a sheer coincidence that we've got that. What's actually happened here is, well, if I look here, I did say that this has been shifted along by 180 degrees. So I've moved this point 180 degrees on. If I look at it in a different way, I could also consider it flipped over or reflected. So this gives a reflection in the x-axis. So if you have a negative, it gives me a reflection in the x-axis. So if you see that, if you see anything like that, so any function with a negative inside there, it's a reflection in the x-axis. Just as an added thing to see, if I said I had a negative on the outside, that would be a reflection in the y-axis. Okay, so there is a lot to remember there, so that is why I'd highly recommend, even if there's not enough room to do it, get a bit of scrap paper and just imagine you were plotting it accurately. Get a table, draw a table out, it's going to make your life so much easier. I hope that's been helpful. I know it's been a lot to take in, but I'm sure you'll be able to access a lot of marks on the papers because of this.